Section 5.9, Solve Rational Inequalities. We learned to solve linear inequalities after learning to solve linear equations. The techniques were very much the same with one major exception. When we multiplied or divided by a negative number, the inequality sign reversed. Having just learned to solve rational equations, we are now ready to solve rational inequalities. A rational inequality is an equality that contains a rational expression. A rational equality definition. Again, a rational inequality is an equality that contains a rational expression. Inequalities such as 3 over 2x is greater than 1, 2x over x minus 3 is less than 4, 2x minus 3 over x minus 6 is greater than or equal to x, and 1/4 minus 2 over x squared is less than or equal to 3 over x. They are rational inequalities as they each contain a rational expression. When we solve a rational inequality, we will use many of the techniques we used solving linear inequalities. We especially must remember that when we multiply or divide by a negative number, the inequality sign must reverse. Another difference is that we must carefully consider what value might make the rational expression undefined, and so must be excluded. When we solve an equation and the result is x is equal to 3, we know there is one solution, which is 3. Now, when we solve an inequality and the result is x is greater than 3, we know there are many solutions. We graph the result to better help show all the solutions, and we start with 3. The 3 becomes a critical point, and then we decide whether to shade to the left or the right of it. The numbers to the right of 3 are larger than 3, so we shade to the right. And therefore, since it's greater than, we have a parenthesis there and not a bracket because it's not including the value of 3. Now, to solve a rational inequality, we first must write the inequality with only one quotient on the left and 0 on the right. Next, we determine the critical points to use to divide the number line into intervals. A critical point is a number which make the rational expression 0 or undefined. We then will evaluate the factors of the numerator and denominator and find the quotient in each interval. This will identify the interval or intervals that contains all the solutions of the rational inequality. We write the solution in interval notation, being careful to determine whether the endpoints are included. Now come back up here in these examples. This first example needs to have 0 on the right, so we'd have to subtract 1 to the left side. Same thing with the second example. We have a 4 on the right, so we're going to subtract 4. Over here we would subtract x, and here we'd subtract 3 over x. So the goal is to always get 0 on the right, and then we're going to use algebra to be able to determine the term on the left.